Hello students, hope you have an idea about different types of dryers with the previous lectures. Today we discuss about the most important drying method of freeze drying and rotary drying process. Let us see about the introduction about these dryers. Freeze drying is a low thermal processing method to preserve food materials. Freeze drying process was initiated during Second World War period in order to preserve the foods. Further, this method is applied for commercial processing of foods. The first freeze dried product is coffee, but nowadays vegetables, fruits, meats, fish, dairy products can be successfully freeze dried. Though the freeze drying technology is widely used in food processing, recently it takes a major application in food industries in combination with vacuum drying process and spray drying process. Rotary drying process is also used in food processing sector for the selective food materials. Now look into the objectives. After going through this session, you will be able to explain the principle, working and applications of freeze dryer and rotary dryer. To interpret the processing and preservation effect of food in freeze drying and rotary drying methods. Preservation of food is achieved by drying of foods under low temperature is called freeze drying. Freeze drying holds a remarkable place in our multiple advanced technologies, more particularly in the field of food processing. The special characteristic feature of freeze drying process is that it maintains the cell structure, size and shape of the product. Removing moisture prevents a product from deteriorating at room temperature. The dried product will be the same size and shape as the original frozen material and will be found to have excellent stability and convenient reconstitution when placed in water. Freeze dried products will maintain nutrients, color, flavor and texture as like original product. Freeze dried products are packed in suitable packaging material to store up to 25 years at ambient temperature. Now coming to the principle of freeze drying. Freezing is the unit operation in which the temperature of a food is reduced below the freezing point and a proportion of water undergoes a change in a state to form ice crystals. Ice crystals are removed by a process called sublimation is called freeze drying. When a frozen liquid is subjected to phase transition from solid to vapor phase, sublimation takes place. Drying is achieved by subjecting food material to a temperature and pressure below triple point. The major factors that determines the phase which substances takes place depends on the temperature and pressure. This is a multi-stage process and obviously each step is critical. The phase diagram is important aspect which explains the phases of water. The temperature and pressure at which the solid, liquid and vapor phases of a pure substance, that is water, can coexist in equilibrium is called triple point. And in the phase diagram where the hot air drying occurs in gas and liquid phase. Vacuum drying takes place under reduced pressure in gas and liquid phase, and freeze drying occurs in the phases of liquid and gas by sublimation. Let us discuss the components of freeze dryer. The important component is a drying chamber, heating shells, vacuum pump and the condenser. The drying chamber in freeze dryer provides a thermally insulated vessel to accommodate the drying shells. Heaters are provided to supply latent heat of sublimation and the temperature range is between -30 to -150 degree Celsius. The vacuum pump removes all the non-condensable vapors to attain maximum vacuum condition. Conduction and radiation type of dryers are used for commercial purpose. For most commercial freeze dryers, minus 65 degrees Celsius is used as condenser temperature. The condenser collects the water vapor that is released by the product. Coffee is the most common drink produced by freeze drying technology. Liquid foods, small fruits and vegetables, green pepper are highly suitable for freeze drying process. The food material should contamination free, and for selected foods pre-treatment is required. For example, before freeze drying, blanching is the mandatory pre-treatment to inactivate the enzymes present in the food materials. Pre-treated prior to drying of foods such as potatoes, pepper is most important to prevent the enzymatic browning process and inhibits discoloration. Now, look into freeze drying process involves the following operations. First one is freezing of food. The second one, the sublimation phase or primary drying. The third one is the desorption phase or secondary drying. The first one is freezing of foods. Almost all the food materials consist primarily of water that has to be removed to preserve the materials. Since freeze drying is a change in state from solid phase to the gaseous phase, material to be freeze dried must first be adequately pre-frozen. During freezing, the food material is hardened by low temperatures. Most of the food materials that are to be freeze dried, which is a mixture of substances that freezes at lower temperatures than the surrounding water. When the aqueous suspension is cooled, changes occurs in the solute concentration of the product matrix, and as cooling proceeds, the water is separated from the solutes as it changes to ice, creating more concentrated areas of solute. This process is crystallization of ice in food materials with the consecutive process of nucleation and growth. These processes are central to the effects of different freezing rates and subsequent effect on food quality. All food materials freeze when its temperature drops below the freezing point and latent heat has been removed. This is also known as degree of supercooling. The greater the supercooling, the greater the number of nuclei formed. The number of nuclei is greatest in the extracellular space, and they are only formed within the cell when the rate of heat removal is higher. As soon as the nuclei form, they begin to grow by accumulation of molecules at the solid or liquid interface. However, the way they grow depends on the microgeometry and the temperature distribution ahead of the freezing front. Now, let us see the freeze drying process. The sublimation phase or the primary drying is the first phase of freeze drying. The frozen food material is placed in the drying chamber where the chamber pressure is reduced to initiate the sublimation process in the primary drying stage. The drying progresses gradually from the surface to the center of the product. The channels formed by the sublimation ice between the ways of vapor to escape. The margin between the drying layer and frozen layer is known as the sublimation interface. The temperature of the sublimation interface is the critical parameter to be controlled in primary drying process. In the frozen layer, the water vapor released by frozen ice crystal in the product during sublimation and the non-frozen water present in the dried layer travels by diffusion through the pores in the dried layer and get into the drying chamber. The absence of frozen layer represents the end of primary drying process and 90% of the moisture is removed at this stage. Now, let us look into secondary drying process. The secondary drying stage involves the removal of unfrozen water. The secondary drying process starts immediately after the primary drying process. The water bounded by food material is removed by heating under vacuum condition in the secondary drying stage. In general, conduction, convection and radiation modes of heat transfer is supplied to the product. The following product temperatures are usually employed. The first one is the temperature between 10 to 35 degrees Celsius for heat sensitive products. The second one is more than 50 degrees Celsius for less heat sensitive materials. At the end of the second drying stage, two critical factors affecting the shelf life of the products are the residual moisture content in the dried material, the temperature at which the dried material is kept in storage. At the beginning of the secondary drying, the decrease in water content is rapid and the drying speed increases with increasing specific surface of the product. Heat transfer occurs in freeze drying process in the sublimation front through the frozen layer and dried layer. The rate of freezing is 1, the influencing factor on the ice crystal configuration and hence the final porous structure of the freeze dried product. In the primary drying process, maintenance of low temperature will reduce the aroma losses. Now, let us discuss about the types of freeze dryers. Different types of dryers are used depends upon the materials to be dried. The dryers are classified as pilot freeze drying, industrial freeze drying, under that multi-batch freeze drying, continuous freeze drying process, tunnel freeze drying, vacuum spray freeze drying. Now, we will see one by one. The first one is pilot freeze drying. Pilot freeze dryers mainly used for food laboratories and pharmaceutical industries, since they are used to explore possibilities for the preservation of biological materials. They are highly demanded. This type of freeze dryer can be dry the materials in batches consisting of from 2 to 20 kgs of frozen product. The second one is industrial freeze dryers. For industrial applications, large capacity dryer with continuous production is required. The following industrial dryers are employed in food processing industries. The first one is multi-batch freeze dryers. Utilization of resources is minimum in batch type dryers. So as to increase the utilization of available resources, the multi-batch freeze dryers are introduced with number of batch cabinets. In this type of dryers, different types of products are dried simultaneously, and this is in practice in most of the industries to dry the food materials. The second one is continuous freeze dryers. To overcome the disadvantages in batch type freeze dryers, the multiple freeze dryers are used. The continuous type of dryers is economic in terms of labors, large capacity and to get uniform drying. Two types of multiple freeze dryers are available. The first one is static or tray, in which the freeze dried product is stationary on trays. The second one is dynamic or tray-less dryer, in which the product is moved with belt conveyors. The main disadvantage of this continuous method is equipment is huge, complex and difficult to manufacture. The third type is tunnel freeze dryers. Dryer consists of a large vacuum cabinet in which tray carrying trolleys are loaded at one end. The end is discharging end when the dried products are unloaded. The vacuum locks are fixed in each end of the dryer. a low pressure steam is used to heat the plates. In this type of dryers, it is impossible to dry different types of food materials at the same time. The cottage cheese and coffee are the best examples for this method of drying. The next one is vacuum spray freeze dryers. This type of dryer is specially designed for liquid foods such as coffee and milk. Liquids are sprayed at the top of the cylindrical vacuum tower at a very low pressure. The liquid product with 30% pre-concentration is sprayed at the top of the drying chamber. The droplets are freezes in the vacuum cabinet into very small sized particle around 150 micrometers and collected at the bottom of the dryer. Sticking of food particles is totally avoided in this method of drying and considerable flavor loss occurs during this process. Now, coming to the applications of freeze dryer. The food products which are freeze dried have a superior keeping quality and high nutritional profile with appropriate packaging. No case hardening occurs in freeze dried products, less shrinkage, hence the texture of the product is retained. Coming to the coffee products. The brewed coffee from ground beans is pre-concentrated by evaporation and freeze dried immediately to prevent the large ice crystals. Then heat is applied for sublimation process and further drying. The entrapped vapor is remixed into the freeze dried coffee to enhance the flavor. Let's see about the fruit and vegetable products. Most of the fruits and vegetables are suitable for freeze drying process. For example, strawberries should be sliced, then loaded directly into trays and dried with the plate temperature of 50 degrees Celsius. A drying time of 2 hours is possible. The white varieties of mushroom are preferred for freeze drying, pigmented varieties tending to shrink more. They should be peeled, sliced and blanched before being loaded into trays. With a plate temperature of 82 degrees Celsius, a drying time of 3 hours is possible for this type of materials. Now, let's see about shrimp. The pink varieties of shrimp are preferred to the brown for freeze drying. After cooking for 3 minutes, the shrimp is placed in the drying chamber in trays between the plates. The best results are obtained with the plate temperature of around 52 degrees Celsius, which gives a drying time of 10 hours. Higher drying temperatures give a product which dries in 8 hours but rehydrates less well. The product quality is much lower at the higher temperature. Now, look into egg products. Liquid egg is mixed with stabilizers to a thick cream. The mix is then filled into trays to a depth of 10 mm and the product temperature reduced to -25 degrees Celsius. When this temperature is reached, cooling is stopped. Evacuation continues to less than 0.07 kilopascal. Then the plates are heated. The complete drying stage is of the order of 9 to 10 hours and egg is left in trays in the form of crystalline porous cake. The egg is broken up and then sieved into a powder and packed in sacks. Let us see about packaging of freeze-dried foods. Freeze-dried food materials should be sealed in airtight containers to prevent the diffusion of moisture and oxygen. The laminated foil pouches, metal and plastic cans are used for bulk packaging. The vacuum packaging and inert gas packaging is also possible for freeze-dried food materials to prevent oxidation and spoilage of foods. Let's see about the limitations of freeze-dried foods. The first one, which is expensive due to the specialized equipments, which required more storage space, which is more fragile due to its porous nature, which is suitable for selected food materials. The last drying process is rotary drying. The rotary drying is another simple type of secondary dryer often used as a finisher for granulated products. The inside of the drum is fitted with flights on the inner circumference designed to turn the product as it passes through from the feed end to the product other end. The product is agitated by the flights and slowly moved in a helical path inside the drum. Let us discuss about the principle. The rotary dryers are generally used for drying wet granules or grains which do not have tendency to stick. It is a continuous dryer and consists of rotating horizontal cylindrical drum which is slightly inclined to the outlet. Wet material is fed in the upper end and the dry material is discharged from the other end. The cylindrical drum contains lifting flights. As the drum rotates, the flights lift the material to the top from where it tumbles down. Hot air flows at the bottom end upwards, whereas the material flows countercurrently from the upper side to bottom side. Thus, the material is heated by direct contact with hot air by convective heating. In some arrangements, the hot air also passes through the drum. With this arrangement, the drum is also heated and provides conductive heat to the solids when they are in contact with the cylindrical drum. Convective heat is also provided when the solids are tumbling down. When coming to the construction and working of rotary dryer. The rotary dryer is a long rotating cylinder having slope where the feed end is slightly elevated and the discharge end is lower to else easy conveying of the product during drying process. High moist material is fed in the feed hopper through a conveyor or elevator. Then the feed passes into the feed pipe in which slope is provided greater than the natural inclination of the materials, so that the feed material can flow into the rotary dryer smoothly. The cylinder has internal flights or cascades that direct the movement of the product and ensure good mixing and rapid drying. Usually, the solids are discharged at the outlet through a screw conveyor. The dryer drum rotates on drum supporting rolls. The hot air can be blown from the discharge end. In some arrangements, the hot air is sucked from the upper end. Here, the whole dryer is maintained under slight vacuum. This arrangement helps material not to dust and hence is more useful to those materials which have a tendency to dust. The air temperatures are usually used for 120 to 175 degrees Celsius and the air velocities ranging from 2000 to 25,000 kilogram per meter square are for coarse particles. In general, two types of air and feed pattern is preferred according to the properties of the food materials are concurrent and countercurrent. The agitation of the food and the large area of food exposed to air produce high drying rates and a uniformity dried products. The method is especially suitable for foods that tend to mat or stick together in belt or tray dryers. However, the damage caused by impact or abrasion in the dryer restrict this method to relatively few foods like sugar crystals and cocoa beans. Now, let us look into features of rotary dryers. This is applicable for high moisture foods. Wide range of materials invariably with size is applicable in these type of dryers. The highest possible temperature is also applicable. Drying and cooling is also applicable in rotary dryers. Thermal efficiency is high. These dryers are not particularly successful as a drying medium for large particles such as dyes, as the tumbling action tends to distort the shape of the cut and the residence time in the drum is normally insufficient to affect any significant degree of evaporation. Let us conclude this session with the following points. Freeze drying is the low temperature processing method to dry the food materials by sublimation and the most successful method to preserve food materials. Food material undergoes freezing of food, primary drying and secondary drying phases under vacuum conditions to complete removal of water. Depending upon the products, many type of freeze dryers are available to get quality products, and with suitable packaging materials, freeze dried foods are stored for longer time period with good keeping quality. Freeze dryers are highly suitable for coffee, fruits and vegetables, fish and egg products. Low temperature preservation ensures the quality of food materials, and freeze dryer products retain the shape, color and almost all the nutritional qualities. Rotary dryers are highly suitable for granulated food materials which requires proper mixing during drying. The rotary dryers are applicable to continuous process and a larger production capacity products. Rotary dryers are not suitable for sticky and sensitive materials such as sugar crystals and perishables. Hope you got an insight about the working principle and applications of different types of dryers used in food industries. Thank you.